So welcome to the session on implementing Zero Trust Security in API Gateway with Cilium. So this is my first time at Nordic APIs and I'm really excited to be here. So this is me. I'm Pubudu Gunatilaka. I'm a senior technical lead at WSO2. My expertise spans across in the API management domain as well as in key areas like container orchestration systems, service meshes, and other components in the cloud native architecture. So in my talk, I will start looking at the Kubernetes Gateway API and then Cilium. In the latter part of my session, I will go through how we can deeply integrate these technologies and elevate and transform the API management landscape. So let's start examining the application architecture in Kubernetes. So in this case, if you look at the diagram, so what you can see is that the order service is exposed externally with ingress managing the traffic controlling. So if you are familiar with Kubernetes, so this is the declarative format of defining an ingress and a service. And one of the key extensibility features in Kubernetes is that you can define your own definitions in a declarative format for your application needs. And with that, for example, let's say, for just like kind service, you can define a kind called API or a backend or whatever you call it. So with that, you basically integrate your product deeply with the Kubernetes ecosystem. So this is the core foundation. The Kubernetes Gateway API introduced in 2019, which basically addresses the limitations in the ingress specification, and also it introduces API gateway management into the Kubernetes landscape. So unlike in ingress specification, the Kubernetes Gateway API addresses basically brings new phase into the API gateway management, and with some improved traffic routing, security, granular security policies, and with all that, it introduced the role-oriented custom resources. If you look at this, infrastructure provider basically manages the gateway cluster, gateway class, and then cluster operators manages gateway, and then we have the application developer who basically involves in HTTP route creation and for your services. So this role division based custom resources foster a streamlined ecosystem and efficient workflow within the Kubernetes ecosystem. So for example, let's say you want to build an online store and need to expose an order service to the outside world. So the Kubernetes Gateway API makes this possible by defining how your service interacts with the outside world. So this is done mainly using this HTTP route resource. So if you look at this, this specification basically define 4 key sections. The hostname section, that's where you define the hostname for your API to be exposed, and then you have the rules sections. That's where you define multiple rules for your API, and in this case, the pose method is there with the orders resource path, and then you have the filters section. That's where you have multiple filters you can define for your API. So the filters can be URL rewrite, request header modifier. So the URL rewrite filter basically transform your request from orders to order list, while the request header modifier adds a new header into your API request. So under the backend refs, that's where you define your backend service and a pod. So what happens is that when the request lands in, if it matches with the post method with the resource orders, and then these 2 filters are applied, and then eventually the the request is routed to the backend ref, which is the order service. So in the API management landscape, API gateway plays a crucial role, and Envoy proxy has emerged as the preferred choice when creating cloud native environments. It's mainly due to its open source nature and the community driven innovation where it brings. And this Envoy proxy is widely used as a runtime for ingress controllers, mainly due to its running it as a production ready edge proxy. And it also brings API management features like authentication, authorization, rate limiting, and much more on the some of the key features in API management. And it also brings REST and gRPC services, and you have the flexibility there. Where you can write your own code and plug in with the Envoy proxy, like with Lua filters, WebAssembly filters, and native filters as well. So whether you are deploying Envoy proxy as a site kind of service mesh, or a standing tall front proxy in a edge gateway kind of a scenario, Envoy's versatility makes it a more powerful tool in the modern API management landscape. So moving on to the Cilium. Cilium is a more powerful open source uh, technology that revolutionizes networking and security in Kubernetes environments by leveraging eBPF technology. It basically provides unparalleled performance, scalability, and flexibility. It also brings features like efficient networking, granular security policies, seamless integration with service meshes, and deep visibility into the network traffic. So whether you are building a small scale application or a large scale application, uh, Cilium provides the core foundation for reliable, secure, and efficient uh, microservices architecture in the Kubernetes environment. So this is the architecture in Cilium in a Kubernetes environment. So if you look at the control plane here, this is the Kubernetes control plane where you have the Kubernetes API server and other key components. And if you focus to the Kubernetes nodes, those are divided as like user space and the kernel space. The kernel space is where you have your operating system key functionalities like hardware management, memory, and process control operating at a very low level and with full system access. On the other hand, you have the user space, that's where your applications run and that's where your programs run. So interacting with the kernel through system calls, it basically requests for services like networking, memory, and hardware likewise. So what happens is that uh, in Cilium you can define granular layer 3 and layer 4 protocols, network policies, allowing you to do efficient networking and secure communication between Kubernetes workloads. So by this means is that you can control pod interactions, block unwanted traffic, and then you can also do uh, enforcement for like by segmentation. So here the developers are mainly doing like Kubernetes custom resources are being used as Cilium network policies, and then what happens is that Cilium agent basically receives these updates and programs the kernel. So when the request comes in, the kernel will check all these um, policies, and before the request reaches the order port, it will enforce these policies. So this is about layer 3 and layer 4 policies. And moving on to the layer 7 policies, so Cilium goes beyond the traditional network level security by allowing users to define more fine-grained rules based on the application layer information. So what this means is that you can define rules based on the HTTP headers, protocols, or even with some custom configurations. So if you look at an example here, you can restrict the traffic to order port by just adding a header from the Cilium proxy. For example, the order port can be restricted traffic based on the device type header that it receives, right? So in this case, the Cilium proxy can basically add an extra header based on the some HTTP header called user agent. So what as a developer you will be basically deploying similar Cilium network policy, and these are then again available in the Cilium agent. An agent will program the Cilium proxy with all these configurations, and when the requests are coming from the client applications, the request is intercepted at the envoy proxy and then apply these layer 7 policies, and eventually the request is routed to the order port. So Cilium provides traffic management and some of the quality of service features, but lacks the gateway functions like authentication, authorization, rate limiting, and so basic gateway capabilities. So integrating an API gateway is essential for full management of services running on a Cilium. So as shown in the diagram, if we place the API gateway as here, so we can make sure we apply traffic for both north and south, and also we can do east-west traffic management while sending traffic through the API gateway again. So with that, basically we can handle internal as well as external traffics, which adheres to the security and management protocols, thereby enforcing systems more security posture and increasing the reliability and efficiency. So, but this combination of Cilium and API gateway offers benefits, but introduces some challenges. So, complex traffic management and added latency arise from the extra networking layers. Inconsistency policy enforcement between the two systems can create security gaps, while independent scaling risk bottlenecks. So when we are having multiple components, it can complicate monitoring, operation, overhead, and configuration management as well. So we need to rethink the architecture and need to address these issues. So then we wanted to ask ourselves the question whether we really need to have an API gateway inside the Cilium architecture. What if we could incorporate these gateway functions in the Cilium proxy itself? So in our case, our gateway is built on top of Envoy proxy, and Cilium is also leveraging Envoy proxy as their Cilium proxy. So instead of managing two distinct runtime environments, we propose uh, eliminating the separate API gateway altogether and incorporating all these features into the Cilium architecture itself. This approach could simplify our architecture, reduce overhead, and enhance overall efficiency. So going with that direction, so what happens is that if you place the gateway functions in the Cilium proxy itself. This is how it looks like. So there is new Kubernetes operator handling the CRs that applied by the developer, and basically create the Cilium envoy configurations, which again will go to the Cilium agent, and agent will basically programs the Cilium proxy while adding gateway functions into the Cilium proxy itself. So with this architecture, we basically remove the API gateway from the picture, and while we in the runtime layer, we make sure all the capabilities are incorporated into the Cilium proxy itself. So this enhancement significantly optimizes both north-south and east-west traffic management, all while incorporating a robust zero trust security model within the system. So now if we look at the API management architecture with Cilium, so this is how it looks like. Now we have the control plane and the data plane. So the data plane is where you have all your microservices, data services running on a Cilium powered Kubernetes cluster. On the other hand, you have the control plane. That's where your API management portals, like key management and analytics functions run. So the control plane is responsible for sending all these control instructions to the data plane. So with this clear separation, you can deploy multiple data planes, maybe in a different region, maybe in a different cloud, or even with an on-prem environment as well. So meanwhile, there is this control plane, single unified control plane managing all these data planes regardless of their implementation, regardless of their deployed location. So the control plane will do the governance for all these data planes. Now if you look at the API developer and the product management perspective, the API developer is responsible for creating these Kubernetes CRs by incorporating the Kubernetes Gateway API specification, and then this will create an API. So this API will be then visible into the control plane. So that's where the API product manager comes in and attach documentation, open API specification, and like business plans likewise. And then product manager will basically push the API into the developer portal so that external application consumers can come and discover the API and then subscribe to that API. So with that, basically the control instructions are flowing from control plane to the data plane, and the API will be accessible from the data plane. So it is essential to integrate your API management architecture with these developments to effectively prepare for upcoming changes. The Kubernetes Gateway API is set to replace the Ingress specification in Kubernetes, elevating API management within the Kubernetes ecosystem. As a result, gateways are becoming a more commoditized part of the infrastructure, and this specification will dictate how you define APIs in Kubernetes, and broadly as well, not just in Kubernetes basically. And this specification will make sure there is no vendor lock-in, and you can use multiple API management solution or the gateway solution at a given time. And additionally, the integration of Cilium with the API gateway enhances both north, south, and east, west traffic management while establishing a robust zero trust security posture within the system. So with that, I would like to wrap up my session. I hope you found it informative. Thank you very much.